Hello friends, myself Nilufar Abid Khan, Assistant Professor from Kokkananpet, Rahul Darkar College of Pharmacy and Research Institute, Karjat. Today we are going to see alkaloid. Let's start. The term alkaloid or p-phalanxerine was coined by a Messer, a German pharmacist, in 1890. Definition of alkaloid: these are the organic compounds obtained from natural or synthetic origin which are basic in nature and contain one or more nitrogen atom, normally of heterocyclic nature, and possess a specific physiological action on human or animal body when used in small quantity. Physical properties: with few exceptions, all alkaloids are colorless, crystalline solid with a sharp melting point or decomposition range. Some alkaloids are amorphous gum, while the others like conine, spartine, nicotine, etc. are liquid and volatile in nature. Some alkaloids are colored in nature. Example: beta-nidine is red, berberine is yellow, salt of cyanurine or copper red in color. In general, the free bases of alkaloids are soluble in organic, non-polar, immiscible solvent. The salts of most alkaloids are soluble in water. In contrast, the free bases are insoluble in water. Chemical properties: most of the alkaloids are basic in nature due to the availability of lone pair of electron on nitrogen. Types of alkaloids: they are classified broadly in three categories, that is true alkaloid, proto-alkaloid or amino-alkaloid, pseudo-alkaloids. True alkaloid: these are toxic in nature. They contain heterocyclic nitrogen which is derived from amino acid and always basic in nature. True alkaloids are normally present in plant as salt of organic acids. Protoalkaloids or aminoalkaloid: they are simple amines in which the nitrogen is not in a heterocyclic ring. Pseudoalkaloid is the one which includes mainly steroidal or terpenoid alkaloids and purine. They are not derived from the amino acids and they do not show any typical characters of alkaloid, but give the standard qualitative test of alkaloids. Let's see the chemical test of alkaloids. There are four chemical tests, that is Mayer's reagent, that is nothing but potassium mercury iodide solution. When you treat the extract with Mayer reagent, if it shows a cream color precipitate, it indicates that extract contains alkaloids. Next is Dragon-Troff reagent, that is potassium bismuth iodide solution. Treating extract with Dragon-Troff reagent, if it gives reddish brown PPT, it indicates that the extract contains alkaloids. Next is Wagger's reagent, that is iodine potassium iodide solution. It will give reddish brown PPT. Hagel's reagent, that is picric acid, yellow color precipitation is obtained. It indicates that the isolation and extraction process. First, you have to take powdered drug containing alkaloid salts like oxalates, tannins, etc. Defatted if necessary, moist with and render alkaline with solution of sodium carbonate, ammonia and calcium hydroxide. Alkaloids are in free as well as basis form. Exhaust with organic solvent, example chloroform, ether, methylene dichloride, you will get a total extract. This total extract is then divided into two, that is residual organic fraction and aqueous acid solution. The residual organic fractions like pigments, fat, very weak bases or chloroform, soluble alkaloid sulfates. The organic solution of this alkaloid base you have to collect, then you have to remove the solvent and you will get a crude alkaloid mixture. This can be purified by fractional crystallization, chromatographical separation, etc. The phytoconstituent can be identified by using modern techniques like UV, IR, NMR and mass spectroscopy. Aqueous acid solution, that is alkaloid salts, may make alkaline and extract the alkaloid with immiscible solvent, and you will get a residual aqueous fraction. Classification of alkaloid. It is based on the pharmacological classification. It is based on the pharmacological activity. It is classified as pharmacological classification based on its distribution like family, order, genus. It is classified as taxonomical classification based on the precursor which is used for biosynthesis of its phytoconstituent. It is classified as biosynthetic classification, and based on the chemical compound present in it, it is classified as chemical classification. In this chemical classification, there is two distinct divisions, that is heterocyclic alkaloid, that is called as true alkaloids, and non-heterocyclic alkaloid, that is called as proto-alkaloid. Heterocyclic alkaloid, that is true alkaloid, the types are pyrrole or pyrrolidine ring. You can see here the basic ring structures and the examples of it. In case of pyrrole and pyrrolidine, the example is coca species high green. Then next is pyridine and piperidine. Here the examples are trigonelline, conine, arcoline. Pyrrolidine ring, then the basic structure, and with that the example is ischimidine, cineconine, cinecephaline. Next is tropane, that is piperidine and methyl pyrrolidine ring. So the example for this is atropine, hyoscine, hyosamine, cocaine and so on. Next ring is quinoline. Here it is again you have a 6-membered, 2 6-membered with N, that is called as quinoline ring. The example for this is quinine, quinidine, cinchonine, cinchonidine. Next is isoquinoline, in which the N is, instead of having at this position, it is shifted to this area. So it is, you can see the N here. So it is isoquinoline, it is D-tuberculine, berberine, imidine and cephaline. Phenylephrine, which has 3 benzene rings together. Okay, so the example for this is morphine, codeine. Apophine, that is a reduced isoquinoline naphthalene group. Here you can see this is an isoquinoline structure, okay, in which N is substituted with CH3, and this is a naphthalene ring. So this is apophine. The example for this is baldine. Next is indole, that is benzyl pyrrole ring. Here you can see a pyrrole with a benzene, so it is benzyl pyrrole ring. Example for this is argometrine, argotamine, reserpine, vincristine, vinblastine and strychnine. Next is imidazole. It is again a 5-membered ring with 2 N. Example for this is pilocarpine, isopilocarpine and pilocin. Next is norlupinane. It is, you can see a cyclohexane, 2 cyclohexane in between 1 N. Example for this is cysteine, laborine, lupinine, spartine and so on. Next is purine, that is a pyrimidine imidazole ring, in which the 2 rings imidazole and pyrimidine rings joins together. The example for this is caffeine, theobromine and theophylline. And the last from the heterocyclic alkaloid, that is steroidal. It is in cyclopentanone prehydrophenanthrene ring, in which there is 3 cyclohexane group with 1 pentano group. Okay, so the example for this is solacidine, conicine, phentermines and so on. Non-heterocyclic alkaloid, that is a pseudoalkaloid, diterpenes. This is the structure. Example for this is ecotenine, econine, hypoacetinine and so on. And the last one is alkamine, that is amino alkaloid. Example for this is ephedrine, norepinephrine, mescaline. This is the reference. Thank you.